Hello, curious minds. Welcome back to Solar System's Wonders. Today we're setting our sights on one of the most fascinating worlds in our solar system, Mars. From its colossal volcanoes and deep canyons to the traces of ancient rivers, Mars is a planet full of enigmas just waiting to be uncovered. What secrets lie beneath its rust-colored surface? Could life have ever thrived there? Join me as we dive into the mysteries of the Red Planet in this episode. Mars, the Red Planet. It is the fourth rock from the Sun, nestled comfortably between us here on Earth and the asteroid belt, that cosmic junkyard of leftover planetary building blocks. It's about half the size of Earth, but don't let that fool you. It's still a planet of impressive extremes. Now, you might be wondering, why is Mars red? Well, picture this: vast plains covered in iron oxide, essentially rust. You see, on Mars there's plenty of iron and just enough oxygen to create a planet-wide rust-colored landscape. This rusty dust is everywhere, coating the surface and giving Mars its distinctive hue. But Mars is much more than just a dusty, rusty world. It's a planet of dramatic contrasts, with towering volcanoes, ancient riverbeds, and polar ice caps that hold clues to its watery past. Mars has about 38% of Earth's gravity, which affects everything from rover movements to future human missions. The planet also experiences seasons similar to Earth, due to its axial tilt, but they last about twice as long because of Mars's longer orbit around the Sun. And a Martian day, or Sol, is approximately 24.6 hours long, making it quite similar in length to an Earth day. Billions of years ago, Mars was a very different place. Imagine this: rivers flowed, oceans churned, and a thicker atmosphere blanketed the planet, perhaps even supporting a warmer, wetter environment. Some scientists believe that Mars might have even harbored life in its ancient past. But somewhere along the way, Mars took a different evolutionary path than Earth. Its magnetic field, the protective shield that protects a planet from the sun's harmful radiation, weakened. This had devastating consequences. The Martian atmosphere, no longer shielded, was stripped away by the solar wind, leaving behind the thin, wispy shroud we see today. This dramatic climate change transformed Mars into the cold, arid desert we know today. Let's talk about the Martian atmosphere, or should I say the lack thereof. See, on Earth we take our atmosphere for granted. Mars, on the other hand, has an atmosphere that's about 100 times thinner than Earth's. It's like trying to breathe through a straw, on top of Mount Everest, on a particularly chilly day. You wouldn't last very long. And it's not just the thinness that's a problem. The Martian atmosphere is composed mostly of carbon dioxide, with a smattering of nitrogen and argon thrown in for good measure. Not exactly a recipe for human-friendly breathing. This thin, unbreathable atmosphere has some interesting effects on the Martian climate. For example, it can't trap heat very well, which is why temperatures on Mars can swing from a balmy 20 degrees Celsius or 70 degrees Fahrenheit during the day to a frigid minus 153 degrees Celsius or minus 200 degrees at night. Now you might think that a thin atmosphere would make for calm and peaceful weather, but you'd be wrong. Mars is a surprisingly dynamic place, with dust storms that can engulf the entire planet. These dust storms are not your average dust devils. Imagine a swirling vortex of red dust, whipped up by winds that can reach speeds of up to 60 miles per hour. These storms can last for weeks, even months, blanketing the planet in a thick, reddish haze. The thin atmosphere also means that liquid water is essentially impossible on the surface of Mars. Any water that does exist is either frozen as ice or locked away beneath the surface. But don't despair, there's still hope for water on Mars. In fact, recent discoveries suggest that liquid water might exist beneath the Martian surface, perhaps even in the form of vast underground lakes. Let's talk about Olympus Mons. This isn't just a mountain, it's a behemoth, a shield volcano that dwarfs anything on Earth. Its base could cover Arizona, and its peak is 3 times higher than Everest. If Olympus Mons is the king of mountains, Valles Marineris is the queen of canyons. This colossal chasm stretches over 4,000 kilometers, the width of the United States. It makes the Grand Canyon look like a minor crack. We've explored the rugged, rusty surface of Mars, from its enormous mountains to its vast canyons. But what lies beneath? Just like Earth, Mars is a layered planet. Think of it like a cosmic onion, with each layer telling a story. Scientists use techniques like analyzing Martian meteorites and studying seismic waves. The outermost layer is the crust. Mars's crust is much thicker than Earth's. In some places the crust is ancient and heavily cratered. In other regions it's younger and smoother. Below the crust lies the mantle, a region of hot, dense rock. Mars's mantle appears to be relatively stagnant. At the heart of Mars lies a mystery, the core. The core of Mars, much like Earth's, is thought to be composed primarily of iron and nickel. However, unlike Earth's core, which is partially molten and generates a protective magnetic field, Mars's core is likely completely solid. Without this magnetic shield, Mars has been vulnerable to the solar wind's relentless onslaught, which has slowly stripped away its atmosphere over billions of years. There's one question that continues to captivate us. Is there water on Mars? The answer, in a word, is yes. But it's complicated. You see, liquid water is unstable on the Martian surface today. The thin atmosphere and frigid temperatures mean that any water exposed to the surface would quickly freeze or evaporate. However, we see tantalizing evidence of a much wetter past. Across the planet we find ancient riverbeds, dry lake basins, and even evidence of past tsunamis, all suggesting that liquid water once flowed freely on Mars. These features paint a picture of a very different Mars, perhaps even one that could have supported life as we know it. But where did all that water go? Some of Mars's water escaped into space, lost to the solar wind as the planet's atmosphere thinned. But much of it remains, locked away as ice beneath the surface and in the polar ice caps. These ice caps, visible even from Earth, are a testament to Mars's watery past. They grow and shrink with the Martian seasons, a dynamic dance of ice and dust driven by the planet's tilt and orbit. And beneath these frozen reservoirs, scientists believe there may be even more water hidden in underground aquifers. The search for water on Mars is about more than just understanding the planet's past. It's about the search for life itself. For centuries we've looked up at Mars and wondered, what's there? Is there life? Could we go there one day? In recent decades we've sent robotic explorers, and these missions haven't disappointed. Our journey began with flybys. Then came the orbiters like Mariner and Viking. They mapped craters, canyons, and polar ice caps. We saw Mars as a world with a history. To dig deep, we needed to land. Enter the rovers. From Sojourner to Perseverance, they are our eyes and ears. Analyzing soil, drilling rocks, sending data. We found ancient rivers and lakes. Did life ever arise on Mars? We're hot on the trail. Now let's talk about two of my favorite Martian explorers, Curiosity and Perseverance. These two rovers are the heavyweights of Mars exploration, each the size of a small SUV. Curiosity landed in Gale Crater back in 2012. Its mission? To determine if Mars could have ever supported microbial life, and boy did it deliver. Then, in 2021, Perseverance touched down in Jezero Crater. This rover is on a mission to search for signs of past life. Perseverance is also testing technologies like MOXIE, which produces oxygen from the Martian atmosphere. The future is looking bright, or should I say red. Mars has two small companions, Phobos and Deimos. These two are more like potatoes, irregularly shaped and heavily cratered. Phobos, the larger one, whips around Mars 3 times a day. Deimos, smaller and farther out, takes about 30 hours to orbit Mars. Their origins are a puzzle. They might be captured asteroids or formed from debris. The debate continues, making these little moons fascinating. Now you might think, these little moons, what's the big deal? They could play a key role in future human exploration of Mars. Landing on Mars is tricky with its thin atmosphere. But landing on a moon might be easier. From there, you could remotely control robots on Mars. These moons could be sources of valuable resources like water ice. Phobos could become a gateway to Mars. Imagine a base on Phobos, a stepping stone to the red planet. For centuries, humans have gazed at the stars and wondered, are we alone? And Mars, our red neighbor, has always held a special place in that question. Did life ever arise on Mars? Well, we found tantalizing clues, that's for sure. And we've discovered evidence of ancient lakes and rivers, places where life could have thrived billions of years ago. The discovery of complex organic molecules by the Curiosity rover hints at the planet's potential to have supported microbial life in the past. Today, missions like NASA's Perseverance rover and the upcoming ExoMars mission are actively searching for signs of past life. These missions are targeting ancient lake beds and drilling into the Martian subsurface to find biosignatures, clues that life might have once thrived on Mars. One of the most intriguing discoveries is the seasonal spikes of methane detected on Mars. On Earth, methane is often produced by living organisms, sparking debate about whether Martian microbes could be responsible. While it's still unclear if the methane is biological or geological in origin, it adds another layer of mystery to the search. We've landed robots on Mars, driven them around, poked and prodded the Martian soil. That's pretty impressive, right? But we're humans, and our curiosity knows no bounds. The next step is to send humans to Mars. Landing on Mars is not like a quick trip to the moon, it's a longer journey with cosmic radiation bombarding our astronauts. They'll face challenges like setting up a base and growing food, but imagine the possibilities. Humans are adaptable and driven by a thirst for knowledge. We could establish a permanent presence on Mars and explore in ways rovers can't. Think about the scientific discoveries and resources we could utilize. Getting humans to Mars and ensuring their survival is a monumental task. It'll require international collaboration and technological advancements. One of the biggest challenges is developing a spacecraft that can protect astronauts from space travel dangers. We also need to think about sustainability. How will we produce food, water, and oxygen on Mars? The journey to Mars isn't just about reaching a destination, it's about pushing the boundaries of human knowledge. You know, it's fascinating how exploring another planet, especially one like Mars, can give us a whole new perspective on our own. It's like looking at a younger sibling, seeing their path, and maybe getting a glimpse of our own future. Think about it. Mars once had a thicker atmosphere, liquid water, maybe even life. Sound familiar? And now, billions of years later, it's a cold, dry desert. What happened? Was it a cosmic event? Did Mars lose its magnetic field, leaving its atmosphere vulnerable to the sun's wrath? These are crucial questions, not just for understanding Mars, but for understanding Earth's own long-term fate. By studying Martian geology, its ancient riverbeds, and the composition of its polar ice caps, we're piecing together a history. A cautionary tale, perhaps, of how a planet can change over eons. Understanding Mars's climate evolution can help us refine models for our own planet's future climate. As we continue to explore Mars, we find ourselves asking more questions than ever before. Could the red planet hold the key to understanding our place in the universe? What other secrets does Mars have yet to reveal? Thanks for joining me on this journey. If you enjoyed this episode, don't forget to give it a thumbs up, share it with fellow space enthusiasts, and subscribe so you won't miss any future episodes. Next time on Solar System's Wonders, we'll be traveling to the largest and most awe-inspiring planet in our solar system, Jupiter. With its swirling storms, massive moons, and powerful magnetic field, Jupiter is a world of extremes. What mysteries lie within this gas giant, and what can it teach us about the origins of our solar system? Stay tuned to find out. Until next time, keep looking up.